Okay, so let's take a look at section 4.3, which is Law of Cosines. So I'm not going to go through and solve this problem yet. I think this is going to end up being example 1 that I do. But I just want to look at it and ask ourselves why it's different than any other table we've set up all week. What's different about it? Yeah? Joe?
That we don't have a full row.
We don't have a full row. You've got 2 sides and an angle, but the way they gave you the angle, it's in the row where you don't know anything. You don't know the side. So that's a problem. If you tried to set up law of sines to solve this, okay, with law of sines, you've got to pick 2 rows. Well, let's say you pick the first 2 rows. How many things are you missing if you just look at the first 2 rows? 2. That's a problem. You can only be missing 1. All right, let's try 2 other rows. Let's try the last 2. How many are you missing there? 2. You're still missing 2. No, can't do it. Let's try the first and the last row. You're still missing 2. So no matter which 2 rows you try, you're always missing 2 things. Right? Same kind of thing would happen with side, side, side. If you know all 3 sides, you'd be missing all 3 angles, which means no matter which 2 rows you pick, you're going to be missing 2 things. So the law of cosines is used to solve the kind of problem we have up above, which is a side angle side, or side, side, side. So there's an example of side angle side. Okay. 2 sides and an angle, but the angle is between the 2 sides. If the angle wasn't between, then it would be law of sines. It would be side, side angle. And that's the case where you check for the 2 solutions. And then side, 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 that's where you know all the sides. So we've pretty much done every arrangement of S's and A's that you can have, except angle, angle, angle. I never mentioned that one. How come? Why would I never give you angle, angle, angle? Yeah?
You went over this yesterday, but...
Oh, did I mention? Yeah.
Because you can have the same, you can have a 60-degree angle in all of them.
Yeah.
You can have a triangle that has a side of 1s all around, or you can have a side that's like 100 all around.
Yeah, if you don't have one side, you don't have any scale. So you could make a small version of a triangle, and then I could make a larger version of the same triangle, and all the angles are the same. So that doesn't help. You got to know at least one side. So we're still going to label the sides A, B, and C. We're still going to label the angles alpha, beta, and gamma. So I think the first part of this formula you're going to recognize, and if I was going to prove where this formula came from, I would be using what I think you're going to recognize in a second. Okay, what is that? Yeah, it's the Pythagorean Theorem. And there's more. But if I was going to prove what I'm about to show you, the proof would use the Pythagorean Theorem. But it also uses some other things that we haven't learned yet, so I'm not going to go through where this formula comes from. So it kind of starts out like the Pythagorean Theorem. C squared equals A squared plus B squared. But because it's not a 90-degree angle, we have this thing at the end we have to subtract. So it's like you take the Pythagorean Theorem and then you subtract something. What did you subtract? Twice the product of the 2 letters that just came before, so minus 2AB, times the cosine of the angle across from the letter you started with. And the reason I'm reading it like that is because you can start with C, you can start with B, or you can start with A. You can write this formula 3 different ways. But the general idea is one side squared equals the sum of the other 2 squared, minus twice the product of the other 2, times the cosine of the angle across from what you started with. Now, let's pretend that we tried to use this on a problem that had a 90-degree angle. So let's pretend that gamma was a 90. Right? Let's plug in 90 for gamma, and let's take the cosine of 90 and see what happens. So if I take the cosine of 90, I get 0. And then 0 times 2 times A times B would be what?
0.
It would still be 0. So you would be subtracting 0. This whole part disappears when you have a right angle, and it just turns into the Pythagorean theorem. Okay? But when gamma, or whatever the angle is, when it's not 90, that will not be 0. Okay? And then we have to use it. All right, so let's see if we can write it the second way. So the second way starts out b squared. Right? So this one would be b squared equals, what would be my next two sides? Yep.
C squared minus b squared?
It's going to follow the same pattern. None of the signs are going to change.
And c squared plus a squared.
Yep. I'll just put it in alphabetical order. So a squared plus c squared minus, what would come next? Yep.
2ac cosine theta.
Yep. 2 times the product of the two sides that just came before it times the cosine of the angle across from the letter you started with, which is beta. All right, I'm just writing this. I mean, I could write this 100 different ways. I mean, instead of using the letters A, B, and C, I could use X, Y, and Z. And then I could say X squared equals Y squared plus Z squared minus 2YZ. I mean, so I'm just showing you the different ways you can write it. But hopefully after 3, you kind of get the general idea. All right. All right, what would be the last way you could write it using these letters? Yeah.
Equals b squared plus c squared.
So we get the b squared plus c squared, yep.
Minus 2bc.
Minus 2bc, yep.
Cosine x.
Christian?
Alpha.
Alpha.
That's what I was thinking.
Okay. So again, just try to remember the general pattern, especially if you have a problem like a word problem and they don't label anything. You can use whatever labels you want, ABC, XYZ, PQR. As long as you know the general pattern, you can fill in any letters you want. Okay, so as far as explanations, that's pretty much it. All right, so now we know law of sines, we know law of cosines. We have to decide, looking at this problem, which law to use. Okay. Let me make the triangle first. Okay, let's draw it out. Okay, it's not to scale. The only thing that will be accurate is the relationships. What's across from what? So A is 2. Alpha, I don't know. B is 3. Beta, I don't know. C and gamma. Okay, so if I look at that, look at the, oh, and gamma is 60. I should fill that in. Look at the 3 pieces of information that I have. What kind of triangle?
Side angle side.
Yeah, side angle side. 2 sides, angle between them. Okay, so that's SAS. Go back in the notes. SAS says to use law of cosines. Now, this time, in fact, on any side angle side problem, you have to use a certain version first. So if I scroll down, if I call this 1, 2, and 3, only one of those will work right now. Does anyone see which one? And when I say work, I mean you have to have enough stuff to plug in so there's only one thing you don't know. If you plug in and you're missing 2 things, this isn't going to work. Corey?
Number 1.
Yeah, number 1. I've got A and I've got B. So I've got A, I've got B, I've got A, I've got B, and I've got gamma. I've got everything except C. If you try to use 2, right, you've got A, but the problem is you don't have C, and you don't have beta. Okay, if you try to use version 2, you're missing 2 things. If you try to use version 3, you'd be missing 2 things. Okay. So let's plug everything into the first one. So c squared equals a squared plus b squared. So a squared is thinking ahead. Plus 3 squared minus 2 times a times b. 2 times 2 times 3. And again, some of this you could kind of do as you go. I'm going to just write it all out, and then I'll start simplifying after. Times cosine of 60. Okay, so let's simplify some of that. Exponents, what's 2 squared?
4.
4 and 3 squared? 9. Minus, I've got 2 times 2 times 3 times cosine 60. Let's just do 2 times 2 times 3. 12 times cosine 60. Now, order of operations, I still have some more multiplication, so I got to do that before I start looking at addition and subtraction. So let's find out what the cosine of 60 is. Cosine of 60 is a half. So it's 4 plus 9 minus 12 times a half. All right, so c squared equals 4 plus 9. What's 12 times a half? Yep, so we got our minus right there and a 6. And again, I'm really writing out every single step. There's some steps you could skip. But 4 plus 9 gives me 13 minus 6, 7. And now my last step, how do I get rid of the exponent of 2? So we take the square root. And that's the answer for C. Okay.
But isn't that in radians, not degrees?
Well, it's the length of a side. So it might be inches or feet or, whatever it is. But yeah, it's not radians or degrees unless we're getting an angle. So the square root of 7 is about 2.646. Okay, so let's write that down. 2.646. Okay, I'm going to label that in my diagram now. Now, with that labeled, that triangle is not just side angle side anymore. That's what it was, and it still is. But what other triangle is it now? Yeah. Yeah, it's also side, side, side. So I could look at it from that perspective. Or what other type is it? Yeah. You could look at it a couple ways as side, side angle. You have a side, and the angle not between them. Or another side, and the angle not between them. Now, I don't want to look at this problem as side, side angle. How come? What happens if I... What is that one, side, side angle? It's law of sines, and what about that case? That's the 2 solution, no solution, all that stuff. So if I look at this as a side, side angle, then I'm going to have to go through all that stuff. So what I'm going to do is I'm going to use law of cosines one more time to get either alpha or beta. Okay? Okay, so any questions why I'm not going to use law of sines? You can, and if you're careful, it will work. But you have to be careful, okay? Because you just have to be careful. Yeah.
So all of these will only have one answer?
These will only have one answer. Yep. Yep. All the ones I give you only have one answer. Side, side angle always has an answer, no matter what. I could give you a side, side, side problem that doesn't have an answer. Does anyone remember what I said about the sides in a triangle? What's the connection between the sides? Like, it's a quick thing you can check at the end to make sure things are okay. Besides the fact the biggest side's across from the biggest angle. Like, you said that. But there's something else that has to happen with the sides. Yep.
If you add both the sides up, it should be more than the biggest side. The two smallest. If you add the 2 smallest sides, it's bigger than than the biggest side.
Yeah, if you add any two sides, they have to be bigger than the third. So just look at this one. 2 plus 3 is bigger than 2.6. 3 plus 2.6 is bigger than 2. 2 plus 2.6 is bigger than 3. So if you add any two sides, they have to be bigger than the third. So if they gave you a problem with sides like this, that's not going to work. Because if you add up any two sides, they're not bigger than the third. All right. I'm not going to give you one like that, so you don't have to worry about it. But I mean, it is possible in some textbook somewhere they could, okay, or on a test. But I'm not going to give you one like that. Okay, so all of mine will have one solution for law of cosines. Okay, so now we have a choice. We just found, what did we just find? C. Okay, we could do alpha or beta next. It doesn't make any difference. So which one we want to do next? Alpha. Let's find alpha. Okay, to find alpha, I'm going to look at the law of cosines. And this time I'm going to use the third version. It starts out a squared equals b squared plus c squared. Okay, so let's start with that. A squared. Again, I could have done that as I go, but the first time through, I'll just leave it. A squared equals b squared plus c squared. Well, I already had c squared from the last problem. Don't take whatever it was, 2.646 and square it. You're going to get like 6.999, something like that. Just take the exact answer. You have it right there. C squared is 7. So a squared equals b squared plus c squared minus 2 times b times c. So I need b times c. Okay, I'm going to need a calculator in a second to do that. So b times c. 3 times 2.646. So 2 times 3 times 2.646 times the cosine of what angle? Alpha. Okay, so let's simplify what we can. 2 squared is 4. 3 squared is 9. Yes, I can add 9 plus 7, and I could have done it in that step. What's 2 times 3?
6.
6 times 2.646. Gives me 15.876. Okay, so eventually my goal is to get alpha by itself. So there's a lot of things there that I don't want there. Okay, what I have right now is basically something like this. If you can solve this equation, then you can solve the one above it. Right? We have a number equals a number plus a number minus a number times something with a letter. So what would be the next step that I could do? It's actually the same step in both of these equations.
Add 9 plus 7.
We can add 9 plus 7. So 9 plus 7 gives me 15. I mean, 9 plus 7 gives me 16 minus 15.876. I wrote it right, just copy that. So now, what you have is this. A number equals a number minus a number times a letter. What would you do next?
Divide.
We are going to divide, but not yet. It's going to be the step after this step. Corey?
Subtract 16.
Yes, subtract 16 from where?
Both sides.
Both sides. A lot of people, when I don't write it this way, they say, oh, we'll just do 16, take away 15. You can't. You can't because the same reason you can't here. The 15 is being multiplied by a letter you don't know. 16 and 15 are not like terms. Okay? 16 and 15 times something else. So let's bring the 16 to the other side. So minus 16, minus 16. Now we're getting close to having alpha by itself. How would I get the negative 15 on the other side?
Divide.
Yeah, now we would divide. Divide by negative 15, 0.876. Divide by negative 15, 0.876. That's gone. Negatives are gone. Negatives are gone there too. At this point, I like to check it real quick. And always make sure that I have a bigger number in the bottom than the top. If I don't even continue. You did something wrong. Okay, you should always have a bigger number in the bottom. And 15 is bigger than 12. Okay, so now my last step, I have to deal with the cosine function. What are we going to use? Inverse cosine, yep. So take the inverse cosine of what's on the left. Take the inverse cosine of what's on the right. Inverse cosine and regular cosine are gone. And there's your answer for alpha. Okay, let's type it in and see what we get. So second, inverse cosine. Remember, not inverse sine. 12 divided by 15.876. Okay, I know it's rounded, but there's nothing else I can do. I rounded to 3 decimal places. That's pretty accurate. I should be fine. So 40 point, well, technically that's going to round up, so 900 if you're showing the accuracy. 40.900. Right, now at this point, we have 2 out of 3 of the angles. So I can just add them up and subtract from 180. Right. Again, this is the kind of problem that if you made a mistake, the mistake is going to affect a lot of stuff. If you get C wrong, well, then we're going to get alpha wrong, which means we're going to get beta wrong. So just try to be careful as you go through it. So 180 minus 60 minus 40.9 gives me 79.100. Okay, I'm just going to check, make sure biggest side is with the biggest angle. Yep. Smallest side, smallest angle. Okay, it seems reasonable. Any question on that one? So what we really did here, just to kind of look at the big picture, we found 2 different things. We found a side and we found an angle. With side, angle, side, you always have to do that. Okay? Finding a side is really just arithmetic. The letter is pretty much already by itself. Right? The only thing you have to do at the very end is take a square root. When you're finding an angle, it's not just arithmetic, it's algebra. Okay? The letter's not by itself. You have to use algebra to get the letter by itself. Okay? So that's the difference between finding a side and finding an angle. Okay? But those are the only 2 types of things that ever happen in Law of Cosines. It's either like this at the top, or the calculations are like this at the bottom. That's the only 2 things. Any questions on that? Okay, so that's a side angle side. Let's look at side, side, side. So this time we've got 3 sides, no angles, and no row that's complete, so we know it's not a law of sines problem. So next question is, which version of the law of cosines can I use first? Yeah?
Any of them?
Any of them.
All the sides are some one of the angles.
Yeah, you've got all the sides. Anytime you have all the sides, if you go back and look at the formulas, you know everything in every formula up to that dotted line. You have the A, you've got the B, you've got the C. You've got them all. So, what's nice about this is we're kind of back to the problems we did a couple weeks ago in terms of getting things wrong and having it mess other things up. That won't happen here. You can find alpha just using A, B, and C, which was given. You can find beta going back to A, B, and C. And you could find gamma going back to A, B, and C. You don't have to use anything that you find to find anything else here. Also, all of the calculations are going to look like this. Those are going to be the steps. Okay? We're not solving for any sides. So you're not going to do anything that looks like this in this problem. Okay? You're not finding any sides. Okay. So let's pick an angle. It doesn't matter which one. We want to do alpha, beta, or gamma first. Alpha. People usually pick alpha. All right. So how does my law of sines start out, a law of cosines, to find alpha? Yep, Christian?
A squared equals.
Yep.
Oh wait, yeah. Okay, so a squared equals.
All right, let me start with that. So a squared equals.
3 squared plus. 3 squared plus 6 squared.
All right, so I'm just kind of doing it as we go this time.
Yeah.
So a squared equals b squared plus c squared.
And then in parentheses, or the minus, and then parentheses 2 BC.
2bc, so 2, 3, 6.
And cosine alpha.
Find it? Yeah, we're finding alpha. So cosine alpha. Okay, so let's simplify what we've got. 16 equals 9 plus 36 gives me 45. Minus, what's 2 times 3 times 6? 2 times 3 is 6. 6 times 6 is 36 cosine alpha. So already, look how much smaller the problem got. Right? I did all the squaring in my head before we started, and then I did a lot of combining all in one step. Now I have 3 steps left to get alpha by itself. Deal with this, that, and then that. And you do it in that order. Okay, then I just checked them off. So how would I deal with the 45 first? Yep.
Subtract from both sides.
Subtract it. All right, so then when I do 16 minus 45, I get negative 29. All right, now I'm down to 2 things I got to get rid of. Okay, we're just kind of going left to right here. How do we deal with the negative 36?
Add 36 to the sides. Or divide by 36.
Yeah, we're going to divide, and what are we going to divide by? Negative 36. That cancels the number, and the negative, and the negative there. Now at this step, what did I say? Just check real quick, because if you don't have this, you might as well stop at this point. Yep. Right, because you can only take the inverse cosine of a number smaller than 1. If a number is smaller than 1, that means the bottom of the fraction is bigger than the top. All right, so we're good. Last step, I kind of already just said it, but how do we get alpha by itself? Inverse cosine. 29 over 36, and let's see what we get for alpha. So second inverse cosine, 29 over 36, and we get 36.336. Let's try again. 36.336. All right. Now, besides being a side-side-side problem, we could look at it as side-angle side. If you drew it out, you could see that. Or side-side angle. I'm going to stick with law of cosines again because I know there's only one answer to this problem. And law of cosines will give that to me directly. I don't have to play around with second answers or anything like that. So now we can do B or gamma. So at a minimum, you have to do law of cosines twice. Okay? You could do it a third time, and it's safer to do it a third time in terms of having an answer mess up other answers. But what I'm going to do is I'm just going to do it twice, and I'm going to rely on the fact that I got those answers correct, and I'll just subtract from 180 to get the third one. Okay. So to finish up, do we want to do beta or gamma? Which one?
Beta.
Beta. So let's find beta. And can somebody tell me, I know it starts off b squared equals a squared plus c squared. But so I don't have to keep going up and down. Can someone tell me what's b?
3.
3? So 9. And then a?
4.
So 16. And then c? 6. So b squared, a squared, c squared, minus, what are the two letters that come next? Minus 2 ac. 2. A must have been 4, and C was 6. And lastly, times the cosine of, what's the angle I'm trying to find?
Beta.
Beta. Okay. So we'll do all the combining like terms that we can right now. 16 plus 36 gives me how much?
52.
52. 2 times 4 times 6.
48.
8 times 6 is 48. Cosine beta. Okay, I already pointed it out, but what's the thing that you don't want to do right there that some people do and that gets it wrong?
Minus the 48 from the 52.
Yeah, do not do 52 minus 48 and say 4. Can't do that. Okay, got to bring that 52 to the other side. Okay, so now on the right, I've got negative 48 cosine beta, and 9 minus 52.
Negative 43.
Negative 43. Okay, and let's do the last two steps at the same time. Well, Derek, what would be my next step to deal with that negative 48?
To divide by negative 48.
Okay, so I'm going to divide by negative 48. And I still have to deal with the cosine, so I'm going to do the inverse. So take the inverse cosine, and there's our answer. So you can really shorten this up. Like I did that whole thing in like 4 steps. Okay, if you want to write every step out, you'd probably have like 8 or 9 steps. Okay? But you can shorten it. So inverse cosine of 43 divided by 48. So beta is 26.384. Now, if I had extra time and I take enjoyment in the law of cosines, I might do it one more time to get gamma. And then I'd be sure that I didn't cause one mistake to make another mistake. But I'm going to rely on the fact that I got these two right. And I'm just going to add them up and subtract from 180. Does anyone have what you get when you add alpha and beta up and subtract from 180?
117.28.
117.28 must be 280 because 6 and 4 is 0. Okay. So there's your problem. Biggest angles with the biggest side. Yep. Smallest angle, smallest side. Looks good. So any questions on that one? So that's side, side, side. Okay. So the last problem we'll look at is a word problem. I still forgot to bring in that picture about the surveyor measuring the thing that I saw out west. I'll remember it someday. All right, so here it says to find the distance between 2 houses. Okay, a surveyor is going to measure an angle from where they're standing to the 2 houses. Now, if you're thinking, well, why doesn't the surveyor just like take a tape measure, measure the distance between the 2 houses? Well, maybe there's like two cliffs. Maybe a house is on one cliff, a house is on the other cliff, and the surveyor is like 4 miles away on land, and he can see each house, and he wants to know how far apart they are. Okay? Or maybe you wanted to measure the width of the Grand Canyon. You can't exactly just take a tape measure and do that. It's a little big. So you could do something like this. Stand in a spot, take a transit, point it at one side of the cliff, turn it, point it at the other side, and just look at how much you turned it when you went from one side to the other. And that'll tell you the angle. Right. So even though there's a cliff, or maybe there's like a river or whatever between the two houses, the surveyor can walk to one house, and then he can walk over to the other house. You just can't walk between them. Okay, again, there's something between the houses you can't go between. Maybe a big canyon. Yeah?
So like, if the two houses are there, that angle is 70 degrees?
Yeah, I'm going to show you a picture in a second. But yeah, if the two houses are like here and here, and there's some kind of cliff in the middle, the surveyor is right here, and that's the angle right there between the two houses. So we're really making a triangle. So the surveyor then measures the distance to each house, and now really they wouldn't even have to walk the distance off. I think you can really just point a laser at something or use a rangefinder, and it'll just tell you how far away whatever you're looking at is. Did anyone ever use one of those? Rangefinder or like an ultrasonic tape measure? Those are kind of cool. It's pretty neat. Like you just aim it, and it's weird. You almost hear like wherever you aim it, you hear the sound over in that spot, and then it bounces back, and that's how it measures how far it is. It's really weird. It's like if I aimed it in here and like behind you, and it bounced off the wall, like you'd turn around and think something's behind you. It's like you hear the noise over there. It's really weird. I should bring it in sometime, but it's pretty neat and they're pretty accurate. I think it's accurate up to like, mine goes to like 50 feet. So if you want to measure something like miles away, it doesn't really work for that. But it works indoors pretty good. So I just want to know how far apart the houses are. All right, so I said there could be something between the houses that's preventing you from measuring it directly. Could be a cliff, could be a river, could also be poisonous tree frogs. So in our case, we've got poisonous tree frogs. There's our two houses. Okay. Can't walk between them. Now, I couldn't find a picture of a surveyor, but I was able to find a World War II trench soldier. So that's going to be our surveyor. That's what we got. So let's fill in what we know. It says the surveyor measures the angle between the houses to be 70 degrees. I want to draw this nice. Right there. There's your 70-degree angle. Next thing we know is the surveyor measures the distance to houses A and B, and the distance is 50 and 70 feet respectively. So 50 feet to house A, 70 feet to house B. 50, 70. Okay, and the question is how far apart are the houses? So let's just call this X. Okay. What kind of triangle do we have there using our S's and A's? Yep, Corey.
Side angle side.
Yep, side, angle, side. And side, angle, side, which law? Cosines or sines?
Side.
That's cosine. Side, angle, side, that's side, angle, side, 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 that's law of cosines. All right, so we just have to find X. Now, here it's important to just remember the general idea because we don't have anything labeled the way we normally do. So we're just going to plug in what we have and just try to remember the formula. So it starts out 1 side squared equals the sum of the other two. So what am I going to start with? Yeah?
C squared equals squared plus 70 squared.
Yep, and I'm just going to use x because that's what we used. So one side squared equals the sum of the other two minus, someone else tell me what comes next.
Baby.
And I'm looking for numbers. Yep.
2 times 50 times 70.
Yep, minus twice the product of the two sides you just did, 250, 70. And the last thing, times cosine of the angle across from the side you started with. You started with x, the angle across is 70. Okay, so it's just a matter of doing all that out. Some of it we can do out. We're going to need a calculator for the rest. What's 50 squared? 2,500, yep. So 25 is 5 squared, but then add a couple zeros. How about 70 squared? 4,900. This part actually works out nice. What's 2 times 50? 100 times 70. So what's 7,000? We normally say 7,000. You can say 7,000. Does anyone say it that way? 7,000? I always say 7,000. But it's weird. If it was like 7,200, I would say 7,200. But I wouldn't say 7,000. I don't know. You can. It just sounds weird to me. Times cosine 70. Let's see. What's 2,500 plus 4,900? 7,400 minus, I need a calculator now. Let's see, 7,000 cosine 70. So that's minus 2,394.14. All right, so we got that. Next step, subtract those two. So 7,400. And the quick way I'm going to type it in is I'm just going to do 7,400 minus the last answer I had on the screen.
5194.
So 5005.86. 5005.86. And my last step now to get the distance would be square root. So let's take the square root, and I'm just going to do the last answer that I have on the screen. 70.75. So x is about 70.75. And I just want to make sure, I think it was feet. Yeah, everything was measured in feet. Not degrees. Okay, so that's the distance between the two houses. Any questions on that? All right, so now at this point, you should be able to solve any type of problem, law of sines or law of cosines. The test will have 6 questions. Each question has 3 parts, so really it's like you're answering 18. You're solving for 18 things on the test. And I think there's a word problem. I'm about a week late on it, but it's a baseball thing. It could have been a baseball thing. You could have still been playing baseball, but we're not. Which is good. So I'll show you that. And if you're not familiar with a baseball field, I am going to draw you a diagram on the board because you kind of have to know a little bit like bases and how things are laid out. There's all kinds of triangles you can set up in a baseball field to find stuff. So that'll be something with your bonus.
Homework on Halloween?
Yeah. I gotta give you something fun.
It's spooky homework though.
Yeah. This is spooky. So page 274, it's those 6 questions. 9, 11, 13, 17, 25, 27. Okay, tomorrow is a review day. So if you end up finishing the review in class tomorrow, then there will not be any homework tomorrow. And also there is no homework on Friday. So this is your last homework assignment for the term.